Hey everyone, Bas from Cordis SUITE here. Today I will show you how our platform enables you to automatically visualize your data for you based on your user input, and also you can ask questions about your data. So how does that work? In the bottom right corner you can see a washing machine simulation where it's currently draining out the water from the drum. Um, we will use a washing machine since everyone is familiar with a washing. In the top right corner, we can see a chat window where we can ask certain things about our data or what we would like to visualize. So for example, to start, we have a washing machine and the washing machine consists of several components. So we can ask what are the components that the washing machine consists of. So we can ask what are the machine parts. So machine parts are basically classes and components of your system, and each component has its own behavior. So we can see that we have a washing machine, and this washing machine consists of the drum, and the drum consists of a motor, a temperature controller, a water controller, and this water controller has two pumps for the inlet and outlet. So each of these components has its own behavior, and they are described in state machines, which is basically a flow chart of the behavior this component should follow. For example, we could ask all the state machines for the washing machine. So what are the state machines of the washing machine? And then we can see it has five state machines, and for example we would like to visualize the first one, so we can say show one, and then it automatically generates a panel where you can see the states that are currently active and were active in the past. We could do the same for the drum. So the drum is it's one level lower than the washing machine itself. So let's ask the same question. Get the state machine of the drum. And then we will also visualize this state machine. So let's also go for the first one. Show one. And now we can see the state machine in operation of the drum visualized. Let's do it for the motor as well. So we know that the motor is a component of the drum again. So then we have three panels of three different levels. So get state machine of motor. And let's visualize the second one. So right now we can see three panels where three different state machines of different components are visualized. So each of these panels consists of two rows, and the top row are the states and the bottom row are the substates. So for example, in the in operation state machine of the drum, we see here a state that is called washing, and the substates are spinning anti-clockwise and clockwise. Same holds for the one for the motor. So we see here that it was moving and it was accelerating or decelerating since it was changing its speed. And here it was at a constant speed level and was just washing at the desired speed. So this already shows you that your data is now really available to you. You can visualize what each component was doing at a certain moment of time or what it's doing currently, and you can put them underneath each other. So for example, at this moment in time, we can see that the washing, the highest component, was running a washing cycle. The drum was washing and spinning anti-clockwise, and the motor was moving and it was in velocity. So here we can see that, for example, it's decelerating and accelerating. So we could also ask for show the requested and actual speed in the panel. We have certain observers, so we would like to visualize the actual speed and the requested speed, the top two. So create a single panel where both the requested speed and actual visualized. So it created the panel for the requested and actual speed. So we can see that the green light is the requested speed and the yellow one is the actual speed. So now we can see that at this moment in time where we are changing speed of the motor, we can really see it's accelerating indeed. And it's spinning anti-clockwise. So you can really visualize now your data and put them all underneath each other. So now it's visualized for the last 5 minutes, but we could also change it, for example, to the last 30 minutes or to the last hour. It's very easy to change. So we can see that in the simulation that we have a green light and then an orange light and a red light. So we could also ask whether it can visualize this data for us. So we can ask first, what are the observers of the lamp? So what are the observers of the lamp? So right here we have two observers. So it has an observer for whether the lamp is on or off and one for which signal mode. So let's visualize the lamp observer for each of the lamps. So we have a green, an orange and a red light. So show lamp for all the lamps. So now it has created 3 panels where the green light is here, the orange light is here, and here we see the red light. So we have no data for the red light, but that's good since red light normally means that we are in some kind of error state. But even when, maybe if you go to the last 6 hours, then we see that we have some data for the red light. So the red light was on at a certain moment in time. So for the red light, we can see there was a period where it was blinking, so it was turning on and off at a very fast pace. So when a red light is blinking, that does mean there's something wrong possibly. So we can ask some questions about what this means that the red light was blinking. So why was the red light blinking? So after analyzing the data, we can see he has found 2 possible issues that could relate to the red light blinking. He has found a warning that says the offset detected motor speed lags behind set point, and an error that says offset too large, motor speed differs from set point. So he says that these warnings and errors suggest that the motor was struggling to operate at its intended speed, which likely caused the red light to blink as a status indicator of an issue. If you need further analysis or specific data, feel free to ask. So there's something happening in the motor that has caused the machine to go into an error state. So you can see that we can create panels and visualize data within seconds of your internal behavioral data. And you can also really ask questions about what your data means and why certain things happened. Know that Cordis SUITE automatically stores all this internal behavioral data for you, so you do not have to do anything for it. You get it out of the box. Note that this feature can also be used for predictive maintenance. So you have the AI analyze your data over a period of time for weeks or months, and it can discover any fluctuation in your data and predict whether a certain component is likely to fail or not. If you would like to stay up to date with the latest features of the Cordis SUITE, follow us on LinkedIn. Thanks for watching.